test set.
If you guys don't get a great viewing position too, I'm gonna post this as soon as we're done with this demonstration for you guys to refer to if you're not in the first group. So if you're in the first group, definitely get to an area where you can see well.
Yep. So this is the air data test set right here. This is the controller. You can remove it, and we have an extension cord that hooks up to this port over here. And this is going to be your power port, so this will go to the to that outlet.
Let me get in here.
These are your valves. These are manual valves that you can open. Generally, the only time we use these is if, for example, you're going up in altitude or going up an airspeed, and you lose power, and you're not able to bring this down with the controller. You can slowly bleed the vacuum or the pressure using these valves. And so these are the output ports of the air data test set. And that's typically what you'll see. That's typically what you'll see across different test sets, because you'll always have these emergency valves, a controller, and a type of extension. Some newer ones are actually completely wireless. This is our backup test set that we use, but it works just fine. But this is typically what you'll see. And you'll see here, this is the pitot output, this is the static output, and this is the AOA output. We're not going to use the AOA. Usually you see these on aircrafts that have what we call smart probes. And so they kind of take the pitot, static, and AOA all in one unit. But you know, this is a little older, so we're not going to end up using it. We're only going to focus on the static and pitot ports. So over here, we have the extension and we have the power input. So this will be your extension, and this is going to be your power cord. So we just, if someone wants to grab that and hook it up. So right here, it's clearly labeled. There's no way that you can accidentally get these switched up, because these are female pins and those are male pins. So it's just like a cannon plug. You just gotta line it up, and then it'll go until you click in, and then you'll get the red light, meaning that you have power available. And so next, we're gonna go ahead and hook up the extension, since we're gonna be bringing it with us inside the cockpit. So that one goes here. And this one goes to the controller. Like that. So now once you're hooked up, I think you could go ahead and hit the power button. And you'll see these will start to illuminate, and you'll get a blue indication here. And so now it's gonna take a couple of minutes for it to go through its built-in checks as it's booting up, and once it's available, you'll have all the different functions. So we'll just give it a minute or so.
Is there an altimeter? Altimeter in this?
Inside the unit?
Yeah.
Yeah, there is. Yeah. And that's what measures. It measures it, like, I guess, like as an analog, and then it gives you like a digital output, and this will basically translate it so you can have it all here. So this is what it'll look like when it's all booted up. You have your range limits, measure/manual mode, automatic program, calibration, and exit. You also have a help tab and a configuration tab. This is what we use to set the limits, like like on helicopters, they can go up to only a certain altitude. Other aircrafts can go, well above 51,000 feet. But we have the range limit set to the type of aircraft that we work on, so we typically don't go more than 51,000 feet in altitude. So the function that we're only gonna use today is the measure/manual mode. So we're gonna go ahead and click it. It's touchscreen. And you'll see here you have 3 different channels. You have your static channel, your pitot channel, and your AOA channel. So what you're gonna wanna do first, whenever we hook it up, we're gonna go ahead and activate those channels. So you see now it says channel on. So we're gonna do the same thing with the rest. And sometimes this touchscreen's a little finicky, but you got pitot on, and then we're gonna go ahead and activate our AOA anyways, because there's a function here labeled ground. Whenever you press the ground function, if you're up in altitude and you're done with your static checks or your airspeed checks, it'll bring the aircraft back to your local altitude. So maybe today it'll be like around 180 feet in altitude above sea level, depending on the barometric pressure, but it'll bring it back to ambient. So in order for that function to work, you have to have all 3 channels activated. If you only have the 2, it's not gonna work. So that's why we'll have it activated. So then over here, the value over here is showing 1880, and that might be because we're gonna vent it out a little bit. So usually if you're done with your leak checks and everything, it'll kind of have some residual pressure in here. And before you hook it up, you want to go ahead and open these up and just vent it out. So when we first booted up, the value was at about 1800, and now we're dropping down to actual ambient. So we'll let it stabilize. The value now is about 250. And we'll just keep opening it up until it stabilizes. But yeah, it's generally closer to 200-ish. So now that it's stabilized, we can go ahead and close all our ports. And you want to double check that they are closed. Even if you're not going to open these, make sure that they're closed, because if you're trying to go up in altitude or an airspeed and these are open, you're just going to be applying way too much pressure, and the vacuum pump or the pressure pump is going to be working extra hard. And when you deactivate the pumps, like when you're ready for your leak checks, you're going to see the altitude drop drastically at a really high rate, and that's not good for the air data computers on the aircraft. So you could potentially damage the aircraft by doing that. So now it's stabilized. The actual value is around 61 today, so that's good there. So like I said, that's your actual value, and that's your rate right below it. So it'll be in feet per minute. And of course, this is going to be, your value is going to be in feet. You can also change it. There's other checks, like not related to the pitot-static systems, but for like an outflow valve, for example, they'll give you values in PSI or HGI. So you can come over here and change that if you need to. But we generally just use this one for altitude checks. So we're going to leave it altitude feet, and for pitot is going to be in knots. It's going to be the same type of setup here. You have your actual value where it's at, and then your rate is going to be knots in minutes. And so over here where you see these dashes, those are your set points. So you're going to go ahead and set your point to whatever altitude you want to go to. So let's say 2000, hit 2, and you can just hit this one. It's 3 zeros, and then you'll hit enter. And once you get your set point, it'll automatically put a rate of 3,000 a minute. So that's a good rate for this type of aircraft. Always make sure you look in the manual, because different aircrafts will have different max rates. So generally it's like 5,000 feet a minute, but always reference your AMM. There'll always be a note that says do not exceed 5,000 a minute, do not exceed 51,000 feet, do not exceed 400 knots, you know, so always be cautious. So in this case, we're gonna go with 3,000 feet a minute. And so over here on your pitot side, this is your airspeed side. We can set it, for example, to 100 knots. and it'll populate it to 100 knots per minute. It's a little low. It's for this aircraft, we can go up to 300 knots a minute and it'll be fine, but we'll go ahead and set this to 250 to be safe. And so once you get all of that information put in, then you're gonna go ahead and hit execute when you're ready. We're not gonna hit execute because it's gonna activate the pumps. Well, we can. Actually, these are check valves, so it's not gonna go anywhere. So this is what happens when you hit execute. And you don't, when you set the values in for both the static and pitot, you only need to hit the execute once. You don't need to hit it on each side. So when you hit it on any of them, it'll automatically set the test set to for both. And usually it'll just go, it'll show start, and then it'll activate the pumps, and it'll usually say something like balancing, and it takes a couple seconds for it to actually start to go up in altitude. So this is just what it sounds like. This is just the pumps running inside. And there you go. As you can see, that value is climbing, and the rate is 3,000. And then now you see your airspeed starting to go. That value is going up, and then your rate is at 250. So it tries its best to keep it right at that rate. If there's a huge leak, you'll know you have a huge leak when you set your rate for 250, for example, and your rate, like when you start to go, it won't get to 250. It'll like stay stuck like at 20 or 50, and it just doesn't want to go any faster than that. So usually that's an indication that you have a huge leak and you should go ahead and stop. And it does have a function to just go ahead and stop, just like that. If you, for whatever reason, there's an emergency, you can hit stop. And so right now we're at 1975 on our altitude. So we can go ahead and use the ground function. So just simply hit ground, and it'll say start, and then it'll, right here at the bottom, it shows ground. So that's what it's doing right now. There we go. So now we're going down, we're decreasing in altitude. So this will go to the set point of 255, and then this one will go to the set point of 0. So once it gets down to the set points, then it'll just equalize, and then the vacuum pump will shut off. And so that's only then will you be ready to disconnect the probes and everything. So you never want to disconnect or connect the pitot probes or the static probes while this is going up or down, or it's up in altitude already. Because again, like if you disconnect something or there's a huge leak, the rate will drop down drastically, and we don't want that. So another function that we're going to use, and typically we always use when we're doing RVSM checks, you do a type of leak check, it'll tell you to go to a certain altitude. For example, whenever you're checking for leaks, you want to check it at a lower altitude first. You never want to start at ground and go all the way to 30,000. You want to go to something low like 2,000 or 3,000. Because if you go to 30,000 and only then you realize that you have a leak, you have to bring it all the way back down to ground. And again, it can, if it's a huge leak, it'll just start dropping drastically. So whenever you get to your altitude, you're gonna go ahead and hit leak mode, and it changes over to this screen and it'll show leak test. And the manuals will tell you like what to look for. Sometimes like on Bombardiers, it'll say bring the airspeed to 400 knots And then after 5 minutes, make sure that it didn't leak 5 knots. So in 1 minute, you can check it just at 1 minute. As long as it doesn't leak 1 knot at 1 minute, then you're good. If it's close, I would go ahead and do the full 5 minutes and make sure that it didn't exceed 5. So there's a start button here. All that does is it sets a timer, and that timer is already set for 1 minute. I believe you can change it. Yeah, you can change it to however long, but typically we just check it for 1 minute. And so once that timer's done, it'll show you how much it'll give you a reading in altitude, and then the AMM will actually show you too, like how much the acceptable leak rate, or how much altitude or how much airspeed you can leak within the 1 minute. So always refer to that. So once you do that, you can go ahead and go back to your manual mode, and you can go up or down as needed. So whenever you go into leak mode, the vacuum pumps will shut off, and that's when you'll be able to check your rate. So I think we're pretty much ready to go ahead and start hooking up our static ports.